So thank you, everyone, and hello. Today I want to start by talking about maps. So this is a map of London, and I use London because I stole this bit from a friend. He's aware. Copyright to Fred Ebert. And this is a pretty precise map, right? You have a lot of stuff here. You can use it if you need to navigate in all kind of small hidden streets. You have the metro, you have everything. It's really, really useful, except if what you need is the 8 of the building, because you are not going to find it there, right? This map is nice, but like all maps, it's wrong, right, in some ways. So it's not every piece of information you can have in there. And that's expected, because if everything was in there, that would actually be the world, and we would not, it would probably be a bit too big, right? But there are other types of map. Here is a different map of London, which is a touristy map made for kids and that want to learn about what are the touristy bits of London. And as you can see, you don't have as many streets. The scale is all wonky because I highly doubt that these buildings are as big as people. And it's even more wrong. Like, it's really, really wrong. The thing is, if you are a kid, or if you're a tourist, if I was a tourist when I was visiting London, this was really wrong. It's also far more useful than the previous map. Because it tells me where things are, where the important place, what the important places are, what they look like, which is nice when you're a tourist and you don't know if what you are looking at is just a random building or actually an old thing you should visit, because that's what happened in European city, right? And it also only shows you the streets that you are probably going to go through as a tourist going between big, important touristy sites. So this is a more useful map, because while all maps are wrong, some are useful to you. And that depends on what you are doing at the moment. The good thing is that's not only true for maps. That's a more general thing you will find a lot in systems thinking, which is that all models are wrong. By definition, they are models. But the interesting bit is not if they're wrong or right. It doesn't matter that much. What's important is, are they useful? Today, I'm going to talk a bit about, in this talk from Salt to Plowshare, about how I moved, and I hope to move some of you, from using only what I call the Swells model to a Plowshare model. The reason I use these names is just because it's a nice bit with this illustration from Magic the Gathering cards for Plowshare, which I would find funny. I'm not really caring about the naming, just a bit. But the important stuff here is not only are these models useful, but also how do we know what useful mean, and how do we build a model? How do we go from facts and things we see and things we would like to achieve and get into a way which help us navigate? Like the map help us know where we go, how we go there, what to see, what to concentrate on, what to focus on. So, I want to preface with a few caveats, because this is a keynote and I have to make it entertaining, right? But I'm also too much in science to not say that I'm going to say lies. So caveat 1, I'm going to use terms like FOSS, free open source software, open source. I'm not going to use Libre, but free software. I know there are differences between all these terms, right? I know the room in which I am, I understand, I know all this. Trust me, I know. I've been in the same fight on the internet. I'm going to use them interchangeably simply because it doesn't matter for this topic, really, and because it's easy, and I have limited time. The second caveat is that I'm also going to use a broad language in a lot of other aspects of this. I may be really blunt in some stuff. I may use some stuff where it's bad, it's not the thing. This is for the sake of brevity. Yes, there is a lot of difference and complexity and diversity in open source projects and stuff like that. But here, we are looking at the big picture, and you may realize why I'm talking with big pictures and not detailed anecdotal information. So, okay, now that I made everyone bored and I did so, let's go to the important stuff. I'm going to yellow get useful. What does it mean to be useful, right? Because remember, we are talking with models, and models are wrong. If you want to know more about why all models are wrong but some are useful, there is this nicely website done by a friend up there that will dive you into all the research and science about this. So what does useful mean? To get to useful, we need to have some goals. What do we want? What is it that we are trying to achieve, right? And we need to have something that fits in the constraint of reality. Because I love the idea in my youth to have humans in Alpha Centauri. Sadly, it's a few light years away, and that's probably not going to happen anytime soon. Right? So we need to stay within the constraint of reality. And the second thing is it needs to be within our means. Because even if something is possible physically, like the rules of science don't tell us that we are totally delusional, we need to be able to pay for it, and not only pay for it, but make the world we live in, the society we live in, accept them as something we can do, right? We need to have the means to get them done. Because, like, there are some things that aren't going to happen, right? I don't think we're going to do some amazing thing like, I don't know, move everyone to Linux next year. Maybe in 10 years. No, probably not. Maybe in 100 years, but not tomorrow. OK. So what could be these goals? What do we want for the future? And what does the present tell us that it wants? I'm going to be nice here and reuse some and do say some really broad things. Society depends on software, and we don't have a choice anymore. Like, the reality is that society depends on us. Your water comes from a plant that is controlled by software, and if it goes wrong, you are going to have a water problem. Your taxes are done like that. What else? Electricity? Your cops filling reports. We have had a case recently in France where, due to software not working, a case was lost and a young girl was killed. Society depends on software, and that's sadly the reality at this point. Everything. Even we all use our phone far too much, right? All of us are on a laptop, and it's just for work. Which means that we have a problem, which is that software is built. The way software is built is that it encodes a model of the world, right? When you write your software, you write in code how you think the world is and how you think it should work. That's what software is. We write down what we think it should do. So it's the logic, but it's also the software around the logic of the software, right? It's what can I expect from GTK? What can I expect for my for my OS, right? Like random change. Now I need to change everything that uses random, right? What do I expect from the things around me? Like, I think Federico told about moving from vcal to ical, right? Suddenly the API changed, and we need to change our software. And also hardware, right? If you have tried to do anything with RISC-V, you know that. If you have tried to do anything with, I think Microsoft is still trying to make Windows on ARM work. It's still not working really well. Hardware evolved, and we have to deal with it. And the world in general changed. 40 or 50 years ago, if you had built a software for census purposes to get everyone information about the population, you would have probably only have a binary choice for gender. It doesn't mean people were only these two genders before, right? What it means is that the way society and the world looked at it erased that in the way it was important. But when the world changed, society changed, people evolve, and suddenly we discover that our software that is 40 years old and still need to process census data need to deal with, well, far more than that. And that's a good thing, except the software needs to change. So if we base on this, we need software to change over time. We don't have a choice. It's needed because otherwise we get stuck in what was there, and when the world changed, when everything evolved, when the hardware changed, we get stuck with no software, and society cannot run without software anymore. I mean, not well. It means that dependencies, up and down, hardware, downstream dependencies, things that depend on you, or things upstream, or even things laterally that you use but are more living with you, need to change regularly. And that means you, as people that work on the software, need to change it regularly because the dependency have changed downstream and upstream. And so you need to change your software to deal with that change, with these new things. It means we have bugs, right? Because bugs can be thought as the models you wrote in your software is actually not entirely wrong. It's not the one you wanted, right? And the world told you, hey, actually, no, this doesn't work like you thought it was. And that can be a security bug, right? Like, oh yeah, you thought you were not getting an overflow, and you actually get one because, hey, good luck with compilers. But it can also be features or adaptation, right? Suddenly, I need more genders, and that's important. So what can we say as goal? Well, we can say as a goal for software is that it needs to have capacity for change, right? And a way to think about that, is that what we want is maintenance. Why maintenance? Well, because it happens that that's a word that corresponds to what we're asking. But the other reason is maintenance is because you need people that know the software to be able to change it. I will talk a bit more about that later, but mostly you need that, right? Now, we have a goal, right? All software needs some maintenance. At least all software that impact society, and that's bigger than we think usually, but we'll look at that in a second. Now, let's look at the other aspect, because we want things that correspond to reality, right? We also want to build a model here. And the best way to build a model is to start with, OK, what do we know about the world so that we can build from that, because we need to account for that at some point, even if we are wrong. So what do we know about reality? A few choice cuts. We know that 70% to 90%, it depends how you count and how much you trust the studies, of all software running in production, and I mean all software, is free and open source software. I did not put the links for the study in all this because they tend to move, but I put enough words that you can find them with an easy search. 70% of all software is free and open software. So the reality is open source has won. Proprietary software, as written, doesn't run nearly anything in the world. That's simply a fact at this point. Now, that doesn't mean that there is no one writing proprietary software, or that the software that is constituted of all these free and open software is not sold or presented as a proprietary one. The rate is, if you want to enact change, free and open source software is where you do it. Because proprietary software is so small of a part that it doesn't matter. So there are exceptions to that. There are some areas where you can find proprietary software being still the only thing. They are usually quickly disappearing. The exception I would bring is that, no, I don't even bring one. Like maybe printers at this point, sadly. But even that, I'm pretty sure they're running free and open source software under the hood. I'm pretty sure I saw curl license somewhere in my printer lately. So the other thing is that free and open software is bigger than you think. And that's also true for all of us that are dealing with this all the time and should know that. And we know that, but the scale is so big that we cannot integrate this in how we think easily. I want to be clear. So research by a friend, George Brusher, looked at this. He looked at the data across ecosystem. This is true, however you slice and dice it. There are millions and millions of libraries out there. And they are used. This is not just a random project by a student that was abandoned. You can keep them out of the data set, and you still get the same kind of results. The orders of magnitude do not change. Free open software runs everything, and it's bigger than you think. And the way to think about that is sit down and go try to find out all the dependencies you have, or any of the systems you use have. And you will discover quickly that even for systems that say that they, vendor everything, have no dependency, etc., you will end up in the thousands and tens of thousands really, really fast, if not hundreds of thousands. Okay, so our reality is free open source software is everything, more or less, and it's mass in terms of people, in terms of use, in terms of complexity. Okay, now the next thing, we know also that free open software is one person. Nearly every single dependency package, library, call it however you want, when you do the math, and however you slice it, how many things you get rid of in your dataset because you think they are polluting your dataset, is still one person. A project with more than one person is an exception, it's a rarity, it's an outlier that we should cut out of our dataset for analysis. Okay, so what that means is that not only it's one person, which already point to the idea a bit, but we do know that 60 to 85% of free open source software, depending how you count, is a hobby, which means it's done by someone that is not paid or paid really, really a small amount of time to work on it. We have not found in any data set a link between the criticality of the package and library and the fact that the person is paid. So if you combine all of this, what you get is, oh yes, I always forget this one because it's a new one by Andrew Nesbitt. He found that last month. 30% of packages on library, once again, however you slice it, it doesn't change the data, have no maintainers or no known maintainers or responsive maintainers. There is maybe someone we think is a maintainer, but when you try to contact them, there is never a response, or maybe they have not answered to any issue or PR or anything in a year or two. So, reality. The reason we have only one person and stuff like that is that free open software and general software demand niche knowledge and deep niche knowledge, right? You need domain knowledge in all of this. I am a maintainer and a person specialized in float-to-string conversion for some of my hobby packages. I have doubt that anyone in this room even understand what I'm talking about. Or maybe a few, but that's the thing, right? Think about all the stuff you maintain yourself. The reality is there is a lot of niche knowledge you have accumulated over the years. And if someone, a new contributor, coming fresh out of school, know nothing about your domain, has to go deep and work on it, it probably is going to need 6 months to a year just to understand enough to even know what he needs to do. You can go over that by, carving a little chunk of it and giving to them with mentorship and having really precise document of a design and everything. But that's an internship. This is not a contributor that is by full-fledged contributors working by himself. This is not a maintainer. Remember, we want change, and what we want the ability to change. And this ability to change sometimes has to be quick, right? Security bugs come to mind, but they're not the only one, right? Quick change depends on domain knowledge. Otherwise, every time you need to do a change, you need to go in and learn the domain knowledge before you can do the change. Which means that if we did not have people dedicated to every single one of these packages, and remember, 30% of them have no one, then we cannot do quick changes. It's not possible. That can be unsettling, but that's also the reality we are facing. And we are just in reality, not even in model yet. I'm stating fact at this point. Most of them are hobbyists. We know that. We saw that before. Hobby mean free, right? They're doing it for free, as in beer. They're not paid for it. But it also means they do it in their free time, which means a really, really limited amount of resources. From every study I've seen and every discussion I've had with maintainers, a good average is 6 hours per quarter, 2 hours per month, 30 hours a year, approximately, less than that, but it's a good approximation. Some of them will do more, of course, and you will probably remember them. And some of them, and this doesn't count the ones that do nothing, like, as I was saying, in the 30% was we do not know maintainers or a maintainer are not active. They are not counted in that. So they are not even dragging back the average here. So the reality is that all our software is of free and open software. All the free and open software, by the vast majority, is written by hobbyists, which means that most of the software that runs the world is run by hobbyists on 6-hour a quarter. Right. I'm going to sleep well at night. So, okay, that's reality. So we have a goal, right? We know we want things to be able to change because society needs that in software. We need our software to be able to change, being for security or for other reasons, like keeping running on not legacy platforms. We also have our reality check of what it means to have people able to make change. It means that we need to have hobby maintainers. And the change needs to be able to be done on the resources they have, right, in the constraint of 6 hours per quarter. Okay. So we're going to switch track a little bit and talk about models. What are the models we have for free and open source software? How do we think about free and open source software? Right. So there is a thing that I call the SWORDS model. It's an activist-based model. It's the one it's an historical model for free and open source software. And the idea is that basically you have free and open software on one side and proprietary software on the other side, and they are fighting for the attention and the share by customers, by users. So fight, right? We are against the evil. I am on the side of free open source software. I write that on my free time. I'm a maintainer. And proprietary software, so we are fighting, right? The other idea of this model is that free open source software try to build a community of people that will contribute and participate. Contribution can be really large here, right? Documentation, translation, just making people aware, helping them use it, like everything is accepted. But this idea is that free open source is this grassroots movement built from people helping each other and working with each other. Contrary to proprietary, which is just hiring people and making them work, and then we feed it to users. Both can be commercial. I want to try that. I know this is something that is sometimes forgotten and not talked about, but like the idea is not that free open source software is not dealing with money and capitalism and all that stuff, right? It can bring money, can pay developers. That's not something that cannot happen. And I know a lot of people here probably have some aspect of that in their life. And this is a historic model, right? This is even the model that was used historically for a lot of thinking through why we do this, what are the goal of this, right? And this is a model that is basically centered on users' rights and freedoms. Because the idea of free and open software is that we give an out, but also to people outside of the proprietary one, but also just control the machine, right? You can do, you have bought your machine, you run your software on it, and you can modify it, you can see it, you know what you are doing. You can know what it's doing, and it's not abusing you. Due to that, this is also a model that is really rooted and linked to digital rights. Rights to transparency, right to some kind of privacy. But we're also seeing recently in stuff around the ability to move stuff, to have some control over your data. And so we see all kind of foundation historically and digital right organization that have built around this idea. And GNOME Foundation is one of them. We can think of the Linux Foundation. We can think of the Apache Foundation. It's slightly different. We can see, or we can think of all FSC Europe come to mind, FS Europe come to mind, Free Software Europe come to mind. These are all organizations built around digital rights, and they work with digital rights organization. This model also makes a lot of sense if you're looking at digital rights or if you're looking at stuff like sovereignty and independence. This is something that is really in light right now in Europe for obvious political reasons. And this is a discussion, a lot of what I'm presenting here come in part from having to talk with policymakers, people from the EU Commission, from European governments. And so this is a discussion that is definitely big right now and has been seized and used by Foundation and Digital Rights Organization to push for more free and open source software using this model in the EU governments. You probably are aware of some of this, but that's a really big push, and that's something we have seen with the EU governments. The tone have changed a bit on that. So, okay, now comes the test. Is this model useful? Because it's wrong in some aspect, like all model, but is it useful? To be useful, remember, we needed to help us achieve our goals, fit the constraint of reality, and be within our means. And so what does this model tell us about how to help software keep running, as we're saying, right? Well, it has a few problems. What it's telling us is probably we should tax proprietary software to be able to finance the open source one, because that's the one that respects everything, that's the one we want to develop, and that's the one we want to maintain. And that's also the one we mentioned was everything, right? Proprietary software is actually free and open source software. The fight doesn't really exist anymore. It's the same code. Proprietary software is, by the vast majority, constituted of free and open source software. If you think of it this way, it's an EE done by free and open source software to proprietary software. You subsume them. Good job. But that means that the separation is not really useful anymore, right? Because it's not like they are fighting, it's the same people. Going commercial makes no sense for hobbyists. A hobbyist cannot and probably do not want to make a business of something that can run on 6 hours per quarter budget. Like, I am not going to be able to sell people a massive amount of commercial software and commercial licenses or any kind of other services if all I can do is run it as a hobby. And if I want to run it as not a hobby, I am an exception. I'm not going to go too deep into this right now, but if you want to talk to me about, we can talk about that. I have a few blog posts about that, and we can go deeper. And same for Foundation. Going commercial doesn't make a lot of sense most of the time because they need to work with this kind of stuff. And also Foundation are here for digital rights, not to make money, usually. It could work, though, going commercial, if we get rid of all the hobbyists. Right? Like, make everything a non-hobbyist, a paid system. I'm sorry, this is a massive change. This is not within our means, and probably not within the realms of reality. This would mean that you would have to pay millions of people a pretty large tech salary, and you would need to build a system to fund that and find a way to manage and administrate this kind of money disgorging. That's not going to happen anytime soon. I'm sorry. I understand why people may want that. I want that too, but that's not happening. There's too many people in too many different ways. And even if we did that, we still have 30% of this freaking stuff that has no known maintainer, or they don't respond. So getting rid of the hobbyists is not going to happen anytime soon. So this model is really useful for sovereignty. It's really useful for digital rights, and that's why I still support it. I have a few donations and stuff like that, and I still believe in this. But it's not useful for our goals of keeping society running. If what we want is maintenance of all this software that runs society, this model is not useful. Doesn't mean it's useless, it's just not useful for this. Okay. Little break. I'm going to drink some water, let everyone, digest the big thing. Okay. How do we build a model that will work then? Because we still need to fix this, right? I mean, I don't know about you, but knowing that all our software, all society depends on this kind of stuff, I would like it to be better, I would like it to be maintained on all. That's still one of my goals. I want to sleep at night. And so to build a model, let's go back to reality. So what does reality tell us? Reality tells us that we have constrained resources, right? There's 6 hours per quarter, 30 hours a year, something like that. This is reality. We cannot work around it, because the only way to work around it is to make all this project not a hobby project anymore. And we just say before, that's probably not going to happen. Okay. When you have a constraint or limited resource that is overloaded, that has too much to do, and I think at this point we will accept that 30 hours per year is probably going to be overloaded for some of these projects. There are 4 solutions. This comes from system research. The first one is shed or reduce the load so that you can do more things at the same time because it's less. You can reduce the quality. Lots of stuff, you don't do them, or you do them less well, you do them faster, you cut corners. Or you can shift work to later. We all know that. That's called making a ticket. Right? And later usually mean never, but that's a different discussion. And 4, you can add more resources, right? You can suddenly, instead of 1 person with 30 hours per year, you can put 2 people, and suddenly you have 30, you have 60 hours per year. Nice, you can do double. This all comes from Joint Cognitive Systems, a book that I really encourage, but that is hard to get these days. Here's the thing. Reduce quality, we already do that. Right? So the reality is that it's not even that we reduced it, that we never raised it. We do what we can with the time we have. And that's not a bad thing. It's just how we get stuff done. That's engineering. Shifting work to later, well, that's what we do all the time. I don't know how many of you have bugs that are, or tickets open for more than 10 years, but I'm pretty sure some of you in this project will know about that, right? Adding more resources, as we saw, we cannot do easily, because that means we move out of hobbyists, and we know that right now maintainers is 1 person, and that's probably not going to change. It's so systemic, it's probably a systemic reality of this system. So we are stuck with shed or reduce load. That's where we need to find solution. Okay, reducing load. How do we do that? How do we do it? Because okay, first of all, what does this freaking mean? And also, what does load even mean here? So what we need to start by doing is understanding load. What does it mean to maintain? And what takes time in maintaining? What's make it take time? And what's eating at that budget? Right. So, maintenance priority. This is not based on data. I'm out of the full fact reality aspect here. This is based on my own perspective and having talked with a lot of maintainers and having interacted with a lot of maintainers over the years. Most important thing, the build system breaks. That's the top priority. Why? Because if the build system breaks, basically my project is not useful anymore. I can maintain all I want, no one can use it. So that's probably the best priority. It's a form of dependency break, but that's not really that useful. But build system is actually a dependency. It's big enough but it's a big enough one to be worth its own category. We are going to talk about dependency break just after, but this is a big enough one that it cannot be only considered as a dependency break. Secondly, is dependency updates, right? Because once again, the world change around me. Upstream and downstream change, and I need to catch up with that. If I write, once again, I'm going to use an example from this morning. If I write a calendar application and everyone moves to iCal and I only manage vCal, well, great, no one uses you anymore, right? So we need that change to keep happening. And that's not only for this, it's also for everything, because dependency updates also bring you new features. And also, if you do not catch up with dependencies, what happens is you are left behind, and then you only run on older machine or on the runtime, or etc., etc. So the next priority, and that's from the most priority to the least, right, it's CI and test suites. And I don't mean here only keeping it running, like, CI is broke, we need to restart the machine or something like that. It's also like just having one and expanding one. Like, once again, if you have looked at any old C project, and C projects are a lot of this free and open source infrastructure that is used everywhere, how many of them actually have tests? Right? And I'm not saying that as a slide to the people, just a reality we're dealing with. And expanding one, because yes, we have some tests. How much does it cover? What does it tell you? I'm pretty sure here most people are used to the fact that you have to expand the test a lot when you get into a new project, because you realize that basically nothing was tested. So this is important, and it breaks all the time too, right? A test broke. Why? Well, because one of my dependency changed, and that changed the result of my test. Okay, and then you have the rest. Yeah, the rest is after these three big ones. And the rest will be bugs. This includes security bugs. It will be new features. It will be functional bugs, as in bugs. It will be also like just, syncing and refactoring and all that stuff. All these come after these. Now, we do this if we have time. Now, I have some bad news. We don't have the time for that. If you're on a 30-hour budget per year, the first three categories of dependency break, CI breaks, and test systems already take all your time, mostly. So you move everything to later. So based on this, based on what we know here, what we have said, what I've brought, what are facts, but also what I just offered as anecdotal data information, is we can build a model which I call the Plowshare model because it goes on that. We want the same amount of work, right? But we have 30 hours of work and we cannot get out of it. This is our limit. We cannot do more. We want more useful output out of this 30 hour, right? That's what we want, actually. We want people to do more than the limited amount they can do in this time, right now. And what that means, or at least a model I offer for achieving that, is better tools. Because if you think about it, these three big things that take all our time, right? They are basically tools problem. Now, this model, if you think about the better tools, you now need to ask the question, does it fit the reality? Does it fit limited resource with hobbyists? Yeah, tools, there are some things they can adopt, it's not asking a lot of them. Is it within our means and does it achieve our goals? Well, that's a good question. Let's have a look. So the model would be tooling for hobbyist maintainer. And what I mean by that is that tooling that is explicitly designed to work within the constraint and limits and needs of hobbyist maintainers. Because we know that hobbyist maintainers are 50% at least of the code running out there in production. That's the one we need to focus on if we want maintainership, if we want maintenance. So better tool. What do we need? What could it mean? Better build system. No, make is not adapted, even to C. I'm sorry. Auto tools, neither. Masons help, yes, but the ergonomics are still crap for hobbyist maintainer point of view. I'm sorry, I'm not here to shit on it because I love it and I'm trying to implement it in stuff. But the reality is that as an open source maintainer that has 6 hours per quarter to do your things, you are not going to be able to move to Mason anytime soon, and it's probably not going to help you that much. Build systems in general are not built for hobbyists. If you have followed a bit the build system in the past few years, you may have seen Bazel, you may have seen Buck, you may have seen Buck 2, you may have seen, what was it, Pants. I'm probably forgetting a couple others. These are not built for hobbyists. And that makes sense, because the people that pay to build them for their own needs, which are quite different. Most hobbyists do not compile Firefox or Chrome, right? And actually, they don't because they cannot. I'm sure everyone here is aware of the difficulty of compiling Chrome, building Chrome. Build systems are not built for hobbyists because there is no money in that, right? This is not proprietary. The proprietary software, any big software, even like you with Mason and everything, don't have the same needs that most hobbyists. Here's your dependency update. That would be nice, right? That's one of these better tools I'm thinking of. In particularly, like just respecting Semver, there is, if my dependency respects Semver, I can check which kind of versioning it has. Like if it's a patch, I can just update. I don't have to think. And that saves me a lot of time because I don't have to go through my tests. I don't have to change everything. It doesn't break on me. Both for better build system and for easier dependency update, we have tools already existing that try to do this and that do it relatively well. If you are in Rust, for example, cargo semver check works really well. And if you think that this is a Rust-only thing, I'm sorry for you, but Predrag, who is the guy behind cargo semver check, has a version for Python that just works. It just doesn't want to deploy it and support it and grow it because he wants to be paid for that work and no one wants to pay him for it. Being able to run tests would be great too. Good testing tool for C, please, because remember, a lot of this stuff is in C. Just being able to run tests in C is already a lot in terms of ergonomics. I think it was, I think for LibreSVG, actually, you talked about this, right? Like, just the ability that in Rust, you write a code and then you write a test and you do cargo test and it just runs. That's it. In C, just putting down the harness and getting it to run is probably going to be 30 hours for a hobbyist that doesn't know about it. Okay, so this could be what it means. Okay, does it achieve our goals? Case study, Rust. Let's have a look at how it works. Compiler that is ergonomic. Yeah, I think that's a good description of Rust. A build system that just works. Cargo build, and you get your stuff. You can cross-compile. It just works. You don't have to define everything. You don't have to go through make. You don't have to define targets. You just cargo build. It works. Test framework that is easy to use and integrated. Yeah, once again, that's what we said, right? It just works. You write a test. You do cargo test. It just works. Nothing else to do. Hobbyist adoption. Yeah, I think we got adoption. I think hobbyists look at this and we're like, OK. Because the other question is, like, we build them better tools. Will they use it? Yeah, I think they kind of adopted Rust. Yeah, I think that's a good story there. I've been a proud member of the Rust Evangelism Strike Force myself. Rewriting it in Rust just happened. Like, I mentioned LibreSVG, but that's not the only one. Everyone is rewriting some stuff in Rust. And that doesn't come from above. Just hobbyists looked at it and say, yeah, if I need to rewrite it in Rust to not deal with the pain of all these bad toolings that I had in C, I'm going to just do it. Right? They even do it coming from Python, or Ruby, or Node, JavaScript. Right? Like, literally, there are teams that have been rewriting the toolings of this programming language in Rust because it was nicer than doing it in their own language. Adoption happens. And we also get new tools. So that's an interesting one. In terms of achieving our goals, remember, we want better quality and better output for the same amount of time. New tools written in Rust. And by that, I mean libraries, stuff that help you write better tools, but also tools themselves. I'm thinking of libgrep, but I'm also thinking of clap, which is the command line parsing and handling tools in libraries that is used a lot in the Rust ecosystem, are just better than everything else in other ecosystems. Like, libgrep is better than nearly everything that try to compete with it. That's just a fact at this point. It's easy to say it's a fact because Burnt Sushi released a massive benchmark with explanation of why and how, so it's easy to say it's a fact because he backed me up. And what we see is massive progress in terms of features, in terms of bug, in terms of safety, because time is unleashed from being spent on build, dependencies, and test. Basically, we can maintain more because we don't spend our time on this stuff. So it's achieve our goals, right? These models, at least what it offers the solutions, seems to achieve our goals. Now, is it within means? I'm going to use Rust because, once again, it's one of the great tools when I have the data. Case study. Rust, a decade approximately from start to 1.0, which is the point where the inflection point for adoption. Adoption happens over time, right? When you provide a new tool that is better, you do not expect all the hobbyists to use it immediately. It doesn't make sense, but that's expected. Cost is pretty contained. So I do not have hard data on this, but I've talked with a lot of people that have been in the managing chain at Mozilla at the time of the Rust team was there. And they estimate that the cost average over the whole time it was there was approximately $1 million per year. This is not nothing, right? I don't have that money. Would love to. But it's achievable. This is not boiling the ocean. 10 years at $1 million, this is a budget that can be offered to policymakers. Right? It's a budget that will make sense. 10 years is a bit long. It doesn't fit into the usual election cycle, but it does make sense for policymaking. The other good news, and that's also a case study from Rust, the research already exists. We are not, if we want to build better tools, we are not going in there blind, having no idea what to do. Right? We are not starting from scratch. There's been a lot of research on how to do it better. If I remember correctly, Graydon Hall, the guys at Launch Trust, as in his own presentation, also regularly in his blog posts, keep pointing out that there was nearly nothing new in Rust. Everything in Rust came from research, and a lot of it comes from the 70s. The most early, like the stuff that come from later, I think the latest one is probably Cyclone for some of the board checking stuff, and it comes from the early 2000s, like 2001 or 2002. Like, we know how to do it. Like, the research exists. We are not going from scratch. We do not have to boil the ocean. This is a really limited investment needed. It's all that is needed, and that's a big all, and I know that. It's like if I was saying just, is bringing this kind of tools and knowledge to industry, building the tool in a way that the industry can use, and that fit the needs of the hobbyist maintainers. That's a pretty safe bet, because we know what to do, we know how to do it, it's just engineering. It's probably going to take 10 years for each project, but that's doable. I did not use it, but another good example would be TypeScript, or the language server protocol, or Visual Studio Code as an example. We know how to do it. We have example. I could also talk of log files. I could talk of all these build tools that languages use now. Like, we know how to do it. Even for C. You can do it for C, I promise you. It may need some rethinking and some feathers that need to be ruffled, but you can. So it's a limited bet. It's a relatively safe bet, even if some of them fail and do not get adoption. We have not spent that much. And the other good news is that, like, there is a lot of hobbyist maintainer, a lot. So any of these bets that works are going to unlock amazing stuff, and that's what we saw with Rust. Right? It's a systemic effect. Okay, so the model become tooling for hobbyist maintainers, right? That's if we want maintainership to get better, if we want security bug to be fixed, if we want all this stuff, like society, to adapt to this change and to get better and not to depend on bad things, what the model tells us is that what's useful, what's a good way to think, and that's not the only way, but it's useful for this particular purpose, is tooling for hobbyist maintainers. And you cannot get rid of any of the aspect of this. That's what I call the Plowshare model, because that's the same stuff. When you look at agriculture, the moment you gave farmers better tools, they produce more food with less human time spent on it. That's the same thing we want. We have a limitation of the amount of time we spent on it. Well then, let's get better output on better things and things that matters more to us as society out of this time. This was from Software Plowshare. I am Thomas Depierre. You can find me at softwaremaxims.com, which is my blog, where I've posted amazing bangers like I'm not your supplier. But mostly, I want you to think about this model, and if you are interested, I will take some questions and try to answer them. Thank you very much. Before I go into Q&A, I have some rules. Comments are OK. I know, you don't expect this one. I yap enough to turn any comment into a question. That's not a problem. But attacks on the data and facts need to respect these rules. You can attack the methodology, but you better be informed about the methodology that was used. OK? Because otherwise, you're just going to spend everyone's time for nothing. Or you can attack with data, but it needs to come from strong studies and reliable stuff. I read a lot of scientific study and research for my free time. I am used to attacking methodological and prime on this, so you need to come with strong stuff. Second thing is, anecdotal attacks on what I just said, on the model and how it works, will be countered by anecdotes or be ignored. You are warned.
So, at your own risk. Questions, comments?
There is one, I think. Everyone else wants food, which I understand.
I'm a little scared to ask this question, but it seems like the obvious one. What about AI? Like as a software development tool? Or
AI?
Yeah.
Does it help with the three things I pointed to?
Well, it can reduce developer workload.
Does it reduce build system? Time spent fixing the build system? I have seen people try. It usually doesn't know how to deal with it because build system is an atrocious thing for sanity. Does it help write better tests? The experiment I've seen with that have not been amazing. It can help a bit with fuzzers, but that's usually not what you need. And it doesn't help write the harness and stuff because the tools are so bad that even if you use it, it's going to break, and fixing it is not something you're going to be able to do. Does it help update dependencies? I mean, you can try. I've not seen a lot of people try because dependencies are going to touch everything in a strange way when it breaks usually because it breaks the models you had. So I would say whatever is done with AI is nice in the rest, and we can maybe talk about it later, but it doesn't matter. Even if it helps, it doesn't help for the stuff that matters.
I'll maybe leave other people in the room to respond to that because they're better qualified than I am.
Oh, I know. But like, I've not seen, right now, I would say that I will take it as a solution when it offers solutions that are baked, that are offered. Right now, I have not seen any uptick in like hobbyist maintainer output, even the ones that have access with AI. Like we do not see, I don't think everyone here has seen a massive raise in quality, features, or bug fix for open source software yet. You may think of exceptions, but I mean, we are talking the large here, right? We're talking of the 50 to 80% that are done by hobbyists.
Thank you for our presentation. I agree with what you said about tooling, because I am the Dame Lines maintainer, and I took the maintainership 6 years ago, and it took me a very, very long time to secure the pipeline, the build system, the dependencies update. But I would like to add something. I think that engineering also helps reducing the amount of work we have to do. I will explain myself. I spent about 2 years refactoring the existing code base because actually the Demlice project is very old. It has almost 20 years today. It's been maintained by many people, so many different practices. And so it took about 2 years to reduce this, what we can call technical debt. And so it has been done with the idea of, okay, I had difficulties to understand the code first, so I want that new contributors understand it more easily. So there is tooling on one side, but there is also engineering that we can do to reduce the complexity and the cognitive complexity to read code.
Totally, and that's part of the ergonomics of this tooling, right? Because your programming language and all are also tooling to help with that. The reason I don't focus on that when I talked about this model is because to be able to do that, you already need to have time to spend on it. And what we're seeing right now, I remember 30% of this library do not have a maintainers or one that responds that is active. Like I agree with you, right? As we're saying, you took something that was already, kind of abandoned or left over and all. You are right, and I want that too. I am not sure it will achieve the kind of impact we want right now, but that's definitely something worth, doing more. And I mean, I can think of a lot of Rust people saying that, for example, the compiler helps them, do that kind of stuff more recklessly because the compiler helps you and supports you. So I totally agree with you. It will help. I'm not sure it needs to be on the top of the list, but it will help.
Hey, since you're talking about hobbyists primarily as a focus and impacting essentially quality of life for hobbyists, what are your metrics? Like if we're going to experiment with trying to do things that impact, I don't know who the hobbyists are.
Yep.
right? So when you're saying things like, you just said, I'm not seeing the impact of this particular tool in the hobbyists of 50%, 80%, I don't know how you're measuring that to verify what you just said. Because I think all I have is anecdotal, and I don't want to talk about it because I will push back with anecdotal evidence for some arguments. But I want to what is your metric? Right. So I can track the same metric and I can do experiments with changes and prove that some of the things you've said are wrong.
Well, I get you. A few things I could offer. It depends what you want to attack. If you want to attack if you want to know how much we get, how much output, if the output get better or not, you can look at, you can actually go talk to maintainers. I know, like, a user study would be great.
No, the question is, what is your metric?
Oh, mine. Oh, but what do you mean by that? How? Right.
And I want to know what your metrics are.
All right. I don't have a metric right now because the model is not at the point when we can pull a metric out. And I know, but if I wanted a metric, like how much they moan, like how much they complain about it, like what is the sentiment, if you go talk to maintainers, what is the sentiment about the tooling? When they are, oh, this build system broke again, do they cite or like, oh, right, yeah, of course, I'm going to fix it.
But you've also categorized your maintainers as hobbyists and not hobbyists.
Yeah.
How did you do that?
Oh, that's easy. You ask them
this
if they're
entire
paid.
setup, how do you know who your hobbyists are and how are you measuring their sentiment?
So for the hobbyists, it's easy. You ask them, and they will tell you if they are paid or not. That's the study that was done by Tidelift. Keep in mind, like Tidelift probably undercounted the numbers of hobbyists because they are a company.
Whoa.
Yeah.
I have people who are paid for some work and not paid for some work. So
you can separate by package.
Are you going deeply into what they are paid for and what they're not?
Yeah. Tidelift did that. Yeah. It's usually not that much of a problem because, I mean, I'm not saying it's not that much of a problem, but that's an important thing. One of the metrics that is interesting on this is if you wanted metrics, we could have also metrics on how many of them are abandoned. We could have, like, the reality of what we want is better result in general in terms of change. So how fast are the security bugs fixed? Like, do people actually have time to look at them? Does the test coverage in general get better? Do we get, like, how long are tickets waitings? We could look at all kinds of things. We should probably also look at sentiment, feelings. How do they feel? Do they feel burnout or not? This is stuff I have not talked about here, but you can find in some of these studies I mentioned, and if you search. Like, but I agree with you that it's underlooked. It's not looked at that much. Another thing you can try, and something I would love to see a better look at, is how fast can you onboard on a project, someone new. And by onboard, I mean actually doing it and seeing it how it works. Because there is a lot of company I've been part of, and also maintainers like FreeOpenSource project, where they tell you just have to run these 3 lines and it just works. And 6 months later, it still doesn't work for me. So there is a lot of metrics you could look at here. I'm not yet at the point where it demands when I look out for them actively, but I don't think it will be that hard to find some. Mostly, like, if you think as, and that's anecdotal, but that's also qualitative, right? If you think as an expert that deal with that stuff a lot, do you consider that right now, if you go dive into these ecosystems and you look at it, are they maintained? Is there someone there that keep pushing updates when they are needed? We know, for example, and that's partially proprietary, but like Log4j, the vulnerable to Log4Shell version of Log4j are still something like 10% of downloads right now from Maven. That means that dependency updates is not done. So how much does this happen? That would be a metric. How fast is the uptake on this kind of stuff? And for less visible security problems too. That would be a start. There is lots of ways to slice that kind of data. One metric will probably not be enough. You want to look at the diversity, but I think that's a good start. But also, like, go ask them. I think that's the thing we don't do enough. And that would probably, like, Rust worked because Graydon was fed up and pushed it. But also, like, do we see adoption? Rust got adopted en masse. Right? Like, if you look at it anyway, like, especially from a system library stuff, right? This is not a space that adopts new tooling fast. Like, you will literally have to have talk telling people to use address sanitizer still in 2026. Rust got adopted really fast on the lot, and people that use it a bit start pushing for it everywhere. That's a visibility that you hit a hotspot. I know it's not perfect. I can't offer you perfect metrics here because I'm more trying to push the model so people think about it and think about this kind of stuff, and even try to tell me I'm wrong, because I would sleep better at night if I was wrong on the rest. But yeah.
Thank you. Well, unfortunately, we don't have time for more questions, but yeah, you are going to have Thomas at the venue, so you can take your time. We have the lunch break now. So thank you very much again.